So we are doing the area capital budgeting under uncertainty. We'll continue with that capital budgeting under uncertainty concepts in today's class also. Please, where we'll be completing that question number 37 which we started in the previous class. Please. Then we will do two more problems involving decision tree and capital budgeting. Then we'll try to cover the following concepts in today's class. Number one is normal probability distribution in capital budgeting, simulation in capital budgeting, risk adjusted discount rate and certainty equivalent approach. The last two are small problems only, should not take more than 15 to 20 minutes to discuss. All these areas will cover in today's class with one important slot that will be pending, which is called as Hiller's model in capital budgeting, which is a continuation over the risk adjusted discount rate approach. Next class will complete the Hiller's model and start with the derivative segment, namely the first chapter called as options in derivatives. Now, we have been doing the chapter capital budgeting in three phases. Phase 1, we completed leasing types of problems. I have to give you the solutions for the practice problem segment. I just ask you some time because I have to type and key in the solution on my own. Since the IPCC batch is getting completed, give me some time. I'll complete that and give you the solution for the leasing area in capital budgeting. The practice problems are homework problems. Number 2, we did the first segment called as capital budgeting concepts. There we discussed so many issues like inflation and capital budgeting, overseas capital budgeting, life disparity, EAB and EAC, abandonment where life disparity will be not taken into account, timing disparity, modified NPV, modified IRR, sensitivity analysis, capital rationing with idle funds, and finally long-term fund approach versus equity shareholders approach, base case NPV and adjusted NPV are all the concepts we discussed in the first segment called as capital budgeting concepts. Now, we started discussing about the third segment in the previous class where I given you the following checklist. Number 1, real options in capital budgeting using decision trees. Number 3 is risk adjusted discount rate approach, certainty equivalent approach, normal distribution and capital budgeting, simulation and capital budgeting, and Hiller's model are all the issues we want to cover in the last segment called as capital budgeting under uncertainty. All this constitutes one big chapter called as capital budgeting. So many issues we have discussed in final level capital budgeting. Whatever I discussed was not in IPCC, it is in addition to what you discussed in the IPCC level. Issue-based approach we had in the capital budgeting at the final level because we don't have value addition nor have time to do the IPCC level problems like calculating a payback period, discounted payback period, IRR, then estimating cash flows, doing capital budgeting. All those areas I did not touch. I'm discussing about the issues or advanced issues in the capital budgeting, in which we started I think with question number 37 where we calculated 6 net present values. Am I right or not? Now, let me summarize that particular question and the discussion before we continue and complete the sum. Okay, please. Full silence. A firm has an investment proposal requiring an outlay of rupees 40,000. Just summarizing the sum here. What is the initial investment for this particular project? Tell me. 40,000. This project is for how many years? I want all of the projects for how many years? 2 years. First year cash flow is certain or uncertain? Uncertain. Whenever I use the word uncertainty, probability will come into picture. Yes or no? Tell me. I estimate the first year cash flow to be either, everybody, either 25,000 or 30,000. What the probability of having 25,000 cash flow? 0.4 and 30,000 is going to be 0.6. Now, this is the cash flow that may happen in year 1. Now, year 2 cash flow depends on what happens in what? Year 1. If year 1 the cash flow is 25,000, year 2 the cash flow may be 12,000, 16,000, 22,000. What the probability of 12, 16, 22? 0.2, 0.3 and 0.4. Or it is year 1, it is 30,000, year 2 maybe what? 20, 25,000, 30,000. What the probability? 0.4, 0.5 and 0.1. Now, the discount rate to be used is 10% for this investment. They have required you to calculate the decision tree, prepare a decision tree showing the possible outcomes and then calculate the expected NPV and other issues. Can I proceed or not? No. My question is, we calculated how many net present values for this particular project? The 6 possible NPVs that are there. Yes or no? No. How 6 NPV? Tell me. First year 25,000, second year 12,000. 1 NPV, situation 1. Situation 2 is what? First year 25,000, second year 16,000. Situation 3, 25,000, 22,000. Situation 4, 30,000, 20,000. Situation 5, 30,000, 25,000. Situation 6, 30,000, 30,000. For all the 6 situations, we have calculated what? Net present value. Respond, are you following or not? No. Look at this. So, this is the NPA for situation 1 minus 7355, like that for situation 2, 3, 4, 5 and then what? 6. All the 6 net present values are computed. Everybody right or not? No. Now let me say prepare the decision tree. This I will do it and then give you time to copy it because you have to plan your page while drawing the decision tree. Once you complete the full decision tree, you will be able to copy it easily. Can you start or not? Now, please participate. We will start with the decision tree calculation. Now, decision tree. Please participate. Now, I have 2 choices. One to what? Invest in the project. Another is what? Do not invest in the project. Everybody following or not? Now, when I invest in the project, tell me first year what may happen? Cash flow can be 25,000 or cash flow can be 30,000. So first year cash flow can be either 25,000 or can also be what? 30,000. Now, from now onwards, note that sometimes I put a box from its arrows emerge. Sometimes I put what? Circle from its arrows emerge. I think you are following or not? Now, it is a custom we should follow. Okay. When I put a box, the arrows emerging are decisions. Are emerging on what? Decisions. From a circle, when the arrows emerge, they are all situations. Are you following? Are you following what I am saying? Now, from a box, when 2 arrows comes out, now those 2 are 2 choices. They are 2 what? Choices. It is in our hand to select one of them. Everybody yes or no? Now, from a circle, when the arrow emerges, they are called as what? Situation. It is not in our hand. It is in whose hand? God's hand. So it is always what? Probabilistic. Respond yes or no. In other words, we call the box as decision box. We call as what? Decision box. And the circle as state of nature. We call circle as what? State of nature. So everybody may not accept God. Everybody accept nature or not. So nature is what? Uncertain. So we call it as what? State of nature. Everybody follow not now. This you should not change everywhere throughout the world. This is a way in which the decision trees are drawn. Can you proceed up? Now, let us continue further. Now, I'll start from the beginning. First, what is my decision now? Invest in a project or don't invest in the project. If I invest in the project, what may happen in first year? First year, I may get 25,000. I may get 30,000. What the probability of 25,000? 0.4. What the probability of 30,000? 0.6. Innappa, right or not? No. Next. First year 25,000. Second year maybe what? Tell me, second year maybe what? 12,000 or 16,000 or 22,000. Respond yes or no. What the probability of 12,000? 0.2. 16,000? 0.3. 22,000? 0.5. Am I right or not? No. First year 30,000. Now what may happen in second year? 20,000, 25,000, 30,000 with the probability of what? 0.4, 0.5 and then 0.1. I want everybody to respond. Are you all following the diagram or not? No. Now, don't invest, nothing is going to happen. The answer is what? 0. Now let us see what happens NPV. You have all the 6 working notes or not? Tell me. First year 25,000, second year what? 12,000. I want the NPV. Minus 7355. Yes or no? No. First year 25, second year 16,000. What the NPV? Minus 4049. First year 25, second year 22. What the NPV? That is 909. First year 30, second year 20. What the NPV? 3801. First year 30, second year 25. What the NPV? 7933. 30 and 30 NPV is 12,065. Respond yes or no? No. That means there are 6 possible NPVs the project may give. Yes or no? Now, look at the 2 words used here. Possible, may give. That means when something is possible and may happen, it should have a probability or not. Whenever we use the word possibility, may, etc., it always have what? Probability. Right or not? Now, for example, the 7355, 4049, for these events to happen, that should be what? A probability. Respond. Are you following up? Now, I want to discuss a small concept with a school level concept only, but still I want to reinforce it before I go for this continuation of this particular problem. Okay. Now, there are 2 types of probabilities. One is joint probability, another is cumulative probability. What are 2 types of probability here? Joint probability and then what? Cumulative probability. In simple English, I can use the word conjunction and or. Understood? And probability and what? Or probability. The 2 types of probability, and probability or probability. Okay. Now, I'll ask you a question. I toss a coin. What is the probability of head? What probability of head here? 0.5. What probability of tails? Yes or no? Correct. Head probability is 0.5. Tails is what? 0.5. The probability of head or tail is what? 1. How it is 1? 0.5 plus 0.5. Whenever while speaking the probability voice, if it is or comes now, you have to add it. You have to add it. That is called as cumulative probability. Respond yes or no. And the addition is possible only when the events are mutually exclusive. Both cannot happen what? Together. So heads or tails, the probability is what? 1. I throw a single dice. I throw what? A single die. 1 dice I throw. How many sides are there in a dice? There are 6 faces. Yes or no? Now, in that, getting 1 in the dice, what the probability? 1/6. Getting 2 is what? 1/6. Getting 3 is what? 1/6. Getting 4 is what? 1. Like that up to getting 60 is what? 1/6. Yes or no? Now, what is the probability of getting 1 or 2 or 3? 1/6 plus 1/6 plus 1/6 is what? 1/2, because 3 out of 6 numbers, anyone you are getting it is what a probability? 1/2. So getting 1 or 2 or 3 is what? Addition, because I use the word what? Or in the probability calculation. I think you are all following or not? I'll give another situation. Now, I don't have 1 dice, I have 2 dice. How many dice here? Dice na 3 ba? What you roll here? Now how many dice here? 2 dice. Okay, now. The 2 dice, in Mahabharata, the player not the same way. There are what? The 2 dice. Because now, don't laugh at me. In one batch, I explained and said dice, you said what it is. Probably my pronunciation not so good, or and in that scenario, people may not be able to understand it. Can I say? Now, 2 dice I'm having, I'm rolling it. Okay, now, see, I give you 2 questions. What is the probability of getting 3 in 1 dice or 3 in another dice? Yes or no? Now, 2 dice I roll here. Okay. In the 2 dice, here 3 should come or what? There 3 should come. Both 3 need not come. 1 3 is enough. It can either be in this dice or what? In that dice. Tell me what is the probability of 3 in this dice? 1/6. What probability of 3 in that dice? 1/6. It means what? 1/6 plus 1/6 becomes what? 2/6 or 1/3 probability. So no, that the probability of getting 3 in this dice or 3 in the other dice. So no. Now, since I use the word or, what did I do? I added it. So no. Now, I put the other question. What is the probability of getting 3 in this dice and 3 in the other dice? Here 3 should be there. There also what? 3 should be there. Tell me, the probability will increase or decrease or decrease. In that case, you should add a multiplier, multiply. Probability of getting 3 in this dice is what? 1 by 6. And 3 in other dice is what? 1 by 6. If you 1 by 6 into 1 by 6. Are you follow what I am saying? Now, when I have two things to happen simultaneously, when I have two things to happen what? Time simultaneously, in that case, it should be what? Multiply. AND gate, we saw seen the Boolean algebra, it is always what? Multiplication. OR gate means what should be what? Added. So AND should be multiplied, OR should be what? Added. I think you are following or not? In the AND probabilities only, we give the name joint probability. We call it what probability? Joint probability. Two things should simultaneously happen. Okay. And or we call as what? Cumulative probability. Always cumulative probability will be adding into 1. Are you following? But joint probability need not add it to what? 1. Can I person not? No. So this is what we want to understand it. Is there clarity? No. So whenever you use the word AND in the probability, it should be what? Multiplied. Or means what? Added. Full clarity is there or not? No. Tell me, to get minus 7335, two things will happen here. First year cash flow should be what? 25,000 and second year cash will be what? 12,000. That means for this 7355 to happen, two activities, one should happen, both should happen, both should happen together, yes or no? The probability what I use is going to be what probability? Joint probability. Respond. Are you following or not? No. Should I add? I should multiply. Multiply. So 0.4 into 0.2 is what? 0.08. Now, to get 25,000 and 16,000, the chance is what? 0.4 into 0.3, 0.12. To get 25,000 and 22,000 is what? 0.4 into 0.5, it is 0.20. Yes or no? To get 30,000 and 20,000 is 0.6 into 0.4, 0.24. 30 and 25, 0.6 into 0.5, 0.30. 30 and 30, it is 0.6 into 0.1, 0.06. Yes or no? Now, all these are mutually exclusive events or not. If I earn 7355, I will not earn what? 4049, so on. Always understand that if I add mutually exclusive probability, that should always total to what? 1. Then only your answer is correct. Enough right or not? Now, if I total the joint probabilities, what total joint probability should be? Obviously what? 1. Everybody following or not? Now, next. I ask you a question. You are doing this project. Answer me. Will you expect an NPV of minus 7355? Will you expect an NPV of 12,065? No. Nobody will expect what? Extreme. Same portfolio theory only. All of us expect only what? Average. When I say average, can I add all the NPVs and divide it by 6? No. When I say what average? Weighted average, because every NPV has got their own probabilities. Respond is or no. Now, so the expected NPV means what NPV? Average NPV, that is weighted average NPV. Everybody following up? Now, if I multiply, I'll be getting minus 7355 into 0.08 gives you this number. Okay, minus 4049 into 0.12, 909 into 0.20, 3801 into 0.24, 7933 into 0.30, 12,065 into 0.06. If I add, I'll be getting expected NPV of 3,124. Is the expected NPV positive or negative or positive? Should I accept or reject the product? Accept the product is the answer for this particular question. Respond yes or no. Please tell me yes or no. No. This is the answer. Let me complete the remaining questions and then give you time to copy. All are one-liners or one-line answers only. Now, let us read the question one by one. Please take page number 66. Top. I read the question. First, construct a decision tree for the proposed investment project. Answer me. Have I constructed a decision tree or not? Yes. What net present value will the project yield if worst outcome is realized? Everything bad happens. What the NPV? Minus 7355, because worst to happen, first year should be 25, second year should be what? 12. So when the worst outcome happens, the NPV is going to be how much? Minus 7355. Accept or not? No. And what is the probability of this NPV? 0.08. Innappa, right or not? No. What is the best case NPV? The best case NPV is 30 case you want, 12,065. What is the probability of this occurrence here? 0.06. That's 8% of having a bad NPV. That's a, say 6% having what? The best NPV. Next. What will the project be accepted or not? Yes, it will be accepted. Why? The expected NPV is positive. Is answer for this particular question. Respond yes or no? No. So NPV for worst outcome is minus 7355. For this the probability is 8%. NPV of the best outcome is 12,065. The probability is 6%. Project will be accepted since expected NPV is positive. Is answer for this particular question. I hope everybody following or not. No. Please, I think up to the working note number 6 or step number 6, you have finished copying or not? No. You should now copy only the decision tree. Please copy this quickly. Copy the decision tree quickly. Please silent copy fast. Let us save some time if you copy as fast as possible. Please. Shh. Stop talking, please. I think you're all copying, na? Your hand will not speak. I'm getting noise, na? Stop talking, please. Stop talking, please. Those not copy, raise your hand. Please. Stop talking, please. Please. Just a moment. Those who have not finished copying, please raise your hand. Please. Shh. Last round, I'll finish copying, huh? Can I proceed? Now, I'll ask you two more questions, you answer, then we can just go for the next problem. Please. Shh. Now, what is the probability that this project will give us a positive NPV? Everybody following on? What is the probability of this project giving a positive NPV? Or I'll put a question back. What is the probability of this project giving negative NPV? Why 0.2? There are two negative NPVs, minus 7355, minus 4049. Probabilities of 0.8 and 0.12. What is the probability of negative NPV? 0.2. What is the probability of positive NPV? 0.8. You can add all the positive probabilities, or also what? 1 minus 0.2 gives you 0.8. Yes or no? Now, tell me, when I said probability of negative NPV, the NPV may be 7355 or what? 4049. Since I use the word or, I added what? The probabilities. Yes or no? That is where we use addition for or and multiplication for what? And. Can I put it or not? Write down note. Write down note. Point number 1. There are two types of probabilities. There are two types of probabilities. Branch it into two. There are two types of probabilities. Branch it into two. First branch, cumulative probability. First branch, okay, cumulative probability. Second branch, joint probability. First branch, cumulative probability. Second branch, joint probability. Cumulative probability, put the down and write. Events are linked by. Events are linked by, within quotes, or. Events are linked by or. Probability of 7355 or what? 4049. The events are linked by or. Second branch, right? Events are linked by, within quotes, and. Events are linked by and. Events are linked by and. Go to the first branch. Events are linked by or na, put a down and write. Add the probability of the events. Add the probability of the events. Add the probability of the events. Linked by and, put a down and write. Multiply the probability of the events. Multiply the probability of the events. Multiply the probability of the events. This is point number 1. Respond yes or no? No. Point number 2. For example, to have a NPV of minus 7355, for example, to have an NPV of minus 7355, to have an NPV of minus 7355, Two events should simultaneously happen. Two events should simultaneously happen. Two events should simultaneously happen. That is, first year cash flow should be 25,000. That is, first year cash flow should be 25,000 and underline the word what? And. First year cash flow should be 25,000 and underline the word and. Second year cash flow should be 12,000 and second year cash flow should be 12,000 and second year cash flow should be 12,000. Since the probabilities are joint, we have multiplied. Since the probabilities are joint, we have multiplied. Since the probabilities are joint, we have multiplied. Respond, are you able to have the clarity or not? Next. Point number 2 or 3? 3. Probability of negative NPV is, probability of a negative NPV is, what the probability of negative NPV is what? 0.08 plus 0.12. Probability of negative NPV is 0.08 plus 0.12 is equal to 0.20. It means our NPV should be, either minus 7355, our NPV should be either minus 7355 or, underline the word or minus 4049. Our NPV should be either minus 7355 or minus 4049. Hence, the probabilities are added. Now, with this we have completed the solution to question number 37. Everybody understanding it or not? Now, let us take question number 36. The problem will look similar to 37, but decision tree will be presented differently. Why different? We'll discuss at the end of that particular problem. There is another type of decision tree for the same type of problem with a small difference. Can you say? Now, take question number 36. Please take question number 36. So, just to say, this problem we in our notebook took from a book called as Brearley Mayer's, but not same problem, but a same type of sum, ditto same type of sum has been given in the second previous RTP. Okay, has been included in the second previous RTP. So could be asked in the examination. Can you see? Now, a company is considering a project involving the outlay of 3 lakhs. Please, past 2 classes, you maintain silence. I was also able to teach peacefully. Right or not? No. Can we maintain that throughout the session or not? Yes, please. Can I proceed? No. A company is considering a project involving outlay of rupees 3 lakhs, which it estimates will generate cash flows over its 2 years life with the probabilities shown below. Year 1 cash flow may be 1 lakh, 2 lakhs or 3 lakhs with a probability of 0.25, 0.5 and 0.25. If year 1 cash flow is 1 lakh, year 2 cash flow will be 0, 1 lakh or 2 lakhs with their respective probabilities given. If year 1 cash flow is 2 lakhs, year 2 cash flow may be 1 lakh, 2 lakhs and 3 lakhs with their respective probabilities given. If year 1 cash flow is 3 lakhs, year 2 cash flow can be 2 lakhs, 3 lakhs and 3 lakh 50 with the respective probabilities given. Tell me, till now this problem is ditto very similar to the previous sum. Respond yes or no? All cash flow should be treated as being received at the end of the year. Even if they don't say so, we assume it to be what? End of the year and use the year and present value factor only. Unless the question specifically says uniformly and use a special present value factor. Are you following up? Now, the company has a choice of undertaking the project either at two sites, A or B, whose costs are identical and are included in the above outlay. In terms of the technology of the project itself, the location will have no effect on the outcome. If the company chooses site B, it has a facility to abandon the project at the end of its first year and to sell the site to an interested purchaser or should be made interested purchaser for rupees 1,50,000. This facility is not available at site A. Company's investment criterion for this project is 10% DCF. What is the word investment criterion? Cost of capital. Criterion means something that should be met. Okay, you should meet an IRR of minimum how much? 10% is the meaning. So the cost of capital is 10%. Its policy would be to abandon the project on site B and to sell the site at the end of the year 1 if it is expected future cash flow for the year 2 will be less than the disposal value. Required, calculate the NPV of the project in site A. Explain based on the above data the specific circumstances in which the company would abandon the project on site B. Calculate the NPV of the project on site B taking into account the abandonment facility. Calculate the financial effect of the facility for abandoning the project on site B, stating whether it is positive or negative is the question. Okay, now please go through the question before you start with the solution. Again I say, not the same sum but the same type of problem has been included in the second previous attempt RTP. Okay, just go through the question before you start with the solution. Shall we start or not? Now, see, this problem data is very much similar or similar to the last sum's data. Yes or no? In a year 1 they gave you some cash flows. Based on that, year 2 cash flow may happen and the decision tree will almost look what? Similar. But the way in which the numbers are going to be put into decision tree, calculations are going to be made is going to be entirely different than what we did in the previous sum. Why it is different and all, we'll compare the two decision trees at the end of the sum and then discuss when to use the previous decision tree approach and when to use the decision tree that is going to be used in this particular problem. We'll be discussing that at the end of the question. First, let me start doing the solution. After every stage, I'll give you time to copy it. Now, here we have only the decision tree. Whatever working notes we have, we'll be doing in the sheet. Along with that, you can also copy as a working note. Can you start or not? Now, let me start with the calculation and the decision tree. Can we start or not? Now, No need to copy anything. First what? Participate. Now, I have a decision. What are two decisions here? Whether to do the project in site A or what? Site B. Site, we can also have third decision not to do what? Project. That can be obvious. Can I proceed or not? Now. So site A, I can do the project. Now, if I do the project in site A, what may happen here? First year, the cash flow can be 1 lakh. Second year, the cash flow can be 2 lakhs. Third year, the cash flow can be 3 lakhs. With the respective probabilities of what? 0.25, 0.5 and then 0.25. Everybody accepting it or not? Now, please participate. Now, first year cash flow 1 lakh. Now, second year cash flow may be what? 0 or maybe what? 1 lakh or maybe 2 lakh. With a probability of 0.25, 0.5, 0.25. Yes or no? Now, first year cash flow is 2 lakhs. Now, second year maybe what? 1 lakh or 2 lakh or 3 lakhs with a probability of 0.25, 0.5 and then 0.25. Accept or not? Those are back able to read the slides, numbers. This say, can I say it? Now, if the first year cash flow is 3 lakhs, the second year cash flow can be 2 lakhs or 3 lakhs or 3 lakhs 50 with a probability of 0.25, 0.5 and 0.25. This is the decision 3 having all the 6 possibilities. Respond yes or no. Okay. Now, I want to find out the expected NPV. I have to find out what? Expected NPV of the project when I do it in which site? Site A. That is my expectation. Yes or no? Now, let us start doing the calculation. Now, you please participate. Now, look at how I am going to approach this particular solution. See, second year, take this particular branch, these 3. Cash flow can be 0 or 1 lakh or what? 2 lakhs. Correct or not? Now, will I expect 0, 1 lakh, 2 lakhs, average? This is going to be what here? Weighted average. Exactly. So, weighted average if I calculate, that is the expected year 2 cash flow. Is or no? If I discount it by 1 year, that is 0.9091, discount it by what? 1 year. The year 2 is brought to year 1. Now, for example, just do one small calculation for you to understand it. 0 into 0.25, please tell me 0 into 0.25 plus 1 lakh into, don't say 0, I know it, yeah. 0 into 0.25 plus what? 1 lakh into 0.5 plus 2 lakh into what? 0.25. This particular tree is going to be how much? 1 lakh. I expect 1 lakh at the end of what? Second year. This is going to be what? 0.9091. This is going to be how much here? 90,910. I write it in lakhs. Okay, 0.9091 lakhs. 90,910 is the second year expected cash flow in first year term. In the yes or no? Now, don't worry, I'll discuss fully and then we can just do it once again. Can I say it? Now, similarly, please help me out. Second year cash flow may be 1 lakh or 2 lakhs or 3 lakhs. First, or Monday, yes or no? Now, second year cash flow can be 1 lakh or 2 lakhs or 3 lakhs. Will I expect 1 lakh or 3 lakhs average? Average. Average means what average? Weighted average. 0.25 into 1 lakh plus 0.50 into 2 lakhs plus 0.25 into 3 lakhs. Calculator, what is the number? The number? 2 lakhs. I expect the year 2 cash flow to be what? 2 lakhs. What is in year 1 term? Discount by what? 1 year. 2 lakhs into 0.9091 gives you what? 1,81,000 odd. I'll write as 1.81 lakhs approximately. Ennappa right or not? Now, please. The expected cash flow in second year can be 2 lakhs or 3 lakhs or 3,50,000. Will I expect 2 lakhs or 3,50,000 average? What average here? 2 lakhs into 0.25 plus 3 lakhs into 0.5 plus 3,50,000 into 0.25. What's the number? 2 lakhs? 87,500. 2,87,500 is at the end of what? Year 2. What is in year 1 term? Discount by 1 year into 0.9091 gives you what? 2,61,000 approximately 2.61 lakhs. Innappa is on no. Please, very simple. 90,910 is the expected year 2 cash flow in what? Year 1 terms. Okay, the cash flow occurs in what? Year 2 and discounted by what? 1 year. So now listen to my word carefully. What is 90,910 expected year 2 cash flow at the end of what? First year when the year 1 cash flow is 1 lakh. English now. If I understood, now you tell me 1,81,000 is expected year 2 cash flow as at the end of what? Year 1. If the year 1 cash flow is 2 lakhs. Now, what is this 2,61,000? Expected year 2 end cash flow as discounted for what? Year 1. If the year 1 cash flow is 3 lakhs. That means this 1 lakh and this 90,000 can be added or not? Yes. This is also received at the end of the first year. This second year then discounted back to what? First year. Both are in same time value. Yes or no? No. That means at the end of first year, my cash flow can be 1,90,910 or 3,81,000 or 5,61,000. Will I expect 1,90,910 or 3,81,000 or 5,61,000 average? Average. What average? Weighted average. So it is 0.25 into 1,91,000 plus 0.5 into 1? 3,81,000 plus 0.25 into 5,61,000. Everybody yes or no? Now, can you tell me please, anybody tell me, it is 1 lakh into, say 1,91,910 into 0.25, memory plus. Yeah, take the, stop, just a minute. I don't want 1 or 2 answering. Class is on everybody is sort of. Now, all of you show your calculator first. To give me a calculator. Now, others, what happened to calculator? See, stop talking. You should not go to a warfare without a sword. I forgot the sword. Now other party will kill you, right or not? Now, you should not come to a class without a calculator. Yeah, it is like a weapon for other subject will kill you. Yeah, right or not? Please do it. Stop. Please. You should have the feel of the numbers. You are not able to understand what I am saying. You should be having a feel of the numbers. So no, now. Stop. Break over. Can I proceed? Listen. First year cash flow. At the end of first year, the cash flow can be what? 1,90,910. What probability? 0.25. 190,910 into 0.25. Put in memory plus. Put in what? Memory plus. Please. 2 lakhs plus 1,81,000, 3,81,000 into 0.5. 3,81,000 into 0.5. Put in what? Memory plus. Now, third is what? 5,61,000 into 0.25. Put in what? Memory plus. It can be any one of the average, no? What average? Please, 3 lakhs? 78,000? Okay, 3,78,478. 3,78,478. Please tell me. This 3,78,478 is discounted cash flow first year end. First year end. Discount by what? 1 year. Into what? 0.9091. Tell me into 0.9091 gives you how much to pay? 3 lakhs? 44,000? 74. 3,44,074. Other discounted inflow minus what? 3 lakh. That gives you what? An NPV of 0.44. Response is or no. Either NPV, if I do the product in what? Site A. Please tell me, are you following what I am saying? Yes or no? No. Please copy this slide. Same, you have to leave another half a page for what? Side B. The diagram is only half part over. Another half part is what? Pending. If you don't know how to copy in one slide, do it in what? 2 sheets. This is my side A. Copy this. I have to dictate the working notes and then go for the side B. Please. Yes or no? Please copy this quickly. Shh. Don't worry. I'll explain this once again when you just do the calculation part in the working notes. Okay. Copy this quickly. Please. Shh. 0.9091 is 0.9091 lakhs. You can even write as 90,910 1,81,000, 2,61,000, and this number is 3,44,000. The number inside triangle are written in lakhs. Okay. Please stop talking. What? Inside circle, only way of presenting. Okay, that is circle represents the state of nature. Above the circle is the relative value. Okay. If you write in the circle, you may see that the number has been highlighted. It won't be representing exactly what state of nature. Only way of presenting it. This is a much more better way of presenting. More clarity will be there. So this side should not be a problem, but those sitting at the far end back, girl side, able to read the numbers or not? If it is difficult, no problem, you have space here, you can come in front and what? Sit, okay. I gave a logical suggestion, what to shout here, okay, now. Please, shh. See, every number if you copy, it will be time waste or time consuming, neck pain will come. You should know the logic of the diagram. First one box, then go site A, 3 options, 1 lakh, 2 lakhs, or not 3 options, 3 situations, 1 lakh, 2 lakh, 3 lakhs. From 1 lakh 3 branches, 2 lakh 3 branches, and 3 lakhs what? 3 branches. Right, the respective probability. Then only 3 triangles has to be written for the 3 circles, and 1 for the first circle, and then 0.4 for the box. That's all. Diagram over, please. If you don't have a clarity in calculation part, don't worry. We'll do all the calculation now through working notes. Okay? At that time we'll be understanding much more better. Stop talking, please. Shh. Those who are not copied, raise your hand, please. Shall I proceed? Now, what you do is, please, shh. Now, such a big diagram we had now, same space one should leave below also, little bit more space also because abandonment option also comes there. Same space plus 1/3 extra, we have to read what below this for side B and then start writing the working notes. Can you understand or not? No. Let's start writing the working notes. Right, working note number 1, please. Shh. Now, very simple here. I am going to tell you how I calculated this 19,910, 1,81,000 and then 2,61,000 as well as 3,44,000 and 44,000. All triangles are calculations for which I have to tell you what? Working notes. Can I say? Right, working note number 1. Please. Shh. Stop talking. Please. This is not correct, I'll say. You have to maintain full silence when the class is on, right or not? Now, write working note number 1. Expected year 2 cash flow, working note number 1, expected year 2 cash flow if year 1 cash flow is 1 lakh. Expected year 2 cash flow if year 1 cash flow is 1 lakh. Expected year 2 cash flow if year 1 cash flow is 1 lakh. Do you understand the heading or not? Underline that. In that right. Expected year 2 cash flow is equal to expected year 2 cash flow is equal to, do along with me, what into what? 0 into 0.25 plus expected year 2 cash flow is equal to 0 into 0.25 plus 1 lakh into 0.5 plus 1 lakh into 0.5 plus what? 2 lakhs into 0.25 plus 2 lakhs into 0.25 is equal to, tell me what is the expected year 2 cash flow? How much rupees? 1 lakh. Expected year 2 cash flow is equal to 1 lakh. Expected year 2 cash flow is equal to 1 lakh. Next line, right? This year 2 cash flow occurs in the second year end. This year 2 cash flow occurs in the second year end. Now, year 2 cash flow comes only in what? End of the second year, no, occurs in the second year end. Full stop. If we discount by 1 year, we bring the expected year 2 cash flow. If we discount by 1 year, we bring the expected year 2 cash flow. We bring the expected year 2 cash flow in year 1 terms. We bring the expected year 2 cash flow in year 1 terms. We bring the expected year 2 cash flow in year 1 terms. I am dictating fully for you to understand it. Everybody following or not? Now, write down which is equal to, right? Which is equal to 1 lakh into 0.9091. Which is equal to 1 lakh into 0.9091 is equal to how much? 90,910. Is equal to 90,910. That's what in slide we write as what? 0.9091 lakh. Tell me, why should I discount by 1 year so that this 1 lakh can be added with what? 90,910 later without any problem regarding time value of money? Yes or no? Now, right, working note number 2. Right, working note number 2. Working note number 2. I want the heading to be told by you, then I'll dictate. What is the heading of working note number 2? Expected year 2 cash flow when year 1 cash flow is 2 lakhs. Exactly. Expected year 2 cash flow when year 2 cash flow when year 1 cash flow is 2 lakhs. Expected year 2 cash flow when year 1 cash flow is 2 lakhs. Expected year 2 cash flow when Year 1 cash flow is 2 lakhs. Year 1 cash flow is 2 lakhs. Can I proceed or not? No. Write down. Expected year 2 cash flow is equal to, you are going to write the answer there. Expected year 2 cash flow is equal to, expected year 2 cash flow is equal to, calculation 1 lakh into 0.25. Write along with me. 1 lakh into 0.25. 1 lakh into 0.25 plus 1. 2 lakhs into 0.5 plus 2 lakhs into 0.5 plus 3 lakhs into 0.25. 1 lakh into 0.25 plus 2 lakhs into 0.5 plus 3 lakhs into 0.25 is equal to how much? Is equal to 2 lakhs. Is equal to 2 lakhs. Next. Expected year 2 cash flow in year 1 terms is equal to, since I explained broadly in the first working note, I am just cutting short it, okay? Expected year 2 cash flow in year 1 terms is equal to, expected year 2 cash flow in year 1 terms is equal to 2 lakhs into 0.9091. 2 lakhs into 0.9091. 2 lakhs into 0.9091 is equal to 1 lakh? 1 lakh 80,000? 1 lakh 81,000? 8? Okay, 1 lakh 81,820. 1 lakh 81,820. We wrote approximately as what? 1.81 lakhs. Leave that hundreds and all. Can I proceed? Now, next. Working note number 3. Working note number 3. Working note number 3. Expected year 2 cash flow. Working note number 3. Expected year 2 cash flow. Expected year 2 cash flow when, please fill in the blanks, when year 1 cash flow is 3 lakhs. Expected year 2 cash flow when year 1 cash flow is 3 lakhs. When year 1 cash flow is 3 lakhs. Underline that. When year 1 cash flow is 3 lakhs, underline that. Okay. Expected year 2 cash flow is equal to, expected year 2 cash flow is equal to, expected year 2 cash flow is equal to, please tell me the calculation, 2 lakhs into 0.25 is equal to 2 lakhs into 0.25 plus 3 lakhs into 0.5 plus 3 lakhs into 0.5 plus 3 lakh 50,000 into 0.25. 2 lakhs into 0.25 plus 3 lakhs into 0.5 plus 3 lakh 50,000 into 0.25 is equal to how much? 2 lakh 87,500 is equal to 287,500. 287,500. Next line. Expected year 2 cash flow in year 1 terms. Expected year 2 cash flow in year 1 terms. Expected year 2 cash flow in year 1 terms is equal to, expected year 2 cash flow in year 1 terms is equal to, tell me what into what? 2,87,500 into 0.9091 into 0.9091 is equal to 2,61,366. 2,61,366, which you approximately wrote as what? 2.61 lakhs. Forget about the hundreds. 261,366. Respond yes or no? No. In most of the batches, a doubt will come. Sir, year 2 to year 1, sir, the P factor is 0.8264. Why you write what? 0.9091. It is wrong. Year 2 to year 0 only, the factor is what? 0.8264. Year 2 to year 1, it is only by what? 1 year. It should be 0.9091. We already discussed this in the bond valuation, forward days calculation, etc. Remember or not? No. So, did you understand the discount rate properly or not? Next. So, working note number 3 over. Yes or no? Now, next is, I have to find out this 3.44 lakhs or not? Now, tell me, expected cash flow at the end of first year. Right now, working out number 4. Expected cash flow at the end of first year. Expected cash flow at the end of first year. Expected cash flow at the end of first year. Expected cash flow at the end of first year. Can I proceed or not? Underline that. Now, can you tell me the calculation? 1,90,910 into 1,90,910 into 0.25. It can be 1,90,910 having 0.25 probability. 1,90,910 into 0.25 plus what? 3,81,000 into 0.5 plus 3,81,000 into 0.5. Are you able to understand or not? Why these two numbers are addable? They are in same time value of money term. Yes or no? And the next is what? 5,61,000 into 0.25. 5,61,000 into 0.25. 561,000 into 0.25. I hope everybody understanding it or not. Now, if I multiply, tell me the number. What is the number here? 3,78,478. Okay, 3,78,478. 3,78,478. This is expected year one cash flow. 3,78,478. Yes or no? Right now, next. Discounted cash inflow. Discounted cash inflow. I use the word discounted because I bring into today's term. Yes or no? Discounted cash inflow is equal to 3,78,478 into 3,78,478 into what? 0.9091. And that is at the end of the year 1. Bring it to what? Year 0. 3,78,478 into 0.9091 is equal to how much? 3,44,074. 344,074. 3,44,074. We wrote approximate is what? 3.44 lakhs. 3,44,074. Respond, yes or no? Now, last working note. Working note number 5. 5 or 4 or 5. NPV of the project in site A. Working note number 5. NPV of the project in site A. NPV of the project in site A. NPV of the project in site A. Can I start or not? Now, right? Expected discounted inflow is equal to tell me the number, 3,44,000. Expected discounted inflow is equal to 3,44,000. I use the word expected because all are averages. 3,44,000 minus. Tell me minus what? Discounted outflow. I did not use the word expected because the number is what? Certain. Minus discounted outflow. What is discounted outflow? 3 lakhs. Minus discounted outflow 3 lakhs. Discounted outflow 3 lakhs. Can you tell me what is the NPV? 44,000. NPV is equal to 44,000. NPV of the product in site A is what? 44,000. NPV is 44,000. Please stop writing, and those who understood fully what has been put in the diagram in the working note, raise your hand. Others, do they understand that side? Can I proceed? No. Let us continue further. Site B, we are doing the project now. Site B or site A, the project is the same project. The project is what? Same project. The cash flows will be same. The probabilities are what? Same. It is ditto copy and paste. Site A is what? Site B. Yes or no? But the site B owner gives me an option saying that if you do this project in site B, suppose you don't want to continue the project after 1 year. I tried for 1 year. I am not happy with that. Then he says, you have an option to abandon. You have an option to what? Abandon. You need not complete the project. At the end of the first year, sell to me the site or the project. Or how much will be sales value? 1,50,000. So there is a guaranteed salvage value or a guaranteed abandonment value that's given by what? The site B person. How much means 1,50,000. I may exercise that option or may not what? Exercise that option. Respond yes or no. When I go for site B, it is having a project, it is having an option. These we call as real options. Earlier in the drug problem, in what problem? The cages problem and all, we have an option to expand. We have an option to what? Expand. Like that, in this problem, we have an option to what? Abandon. I will expand if I like it. I can abandon if I don't want like it. And the project is that the project can be what? Expanded. Here the project is that the project can be what? Abandoned. So there it gives an expansion option. Here it gives me what? An abandonment option. Both the options only for me. Yes or no? Now, before I start, tell me, Site B project also will give me 44,000 NPV. Yeah, NPV better than this, worse than this. And NPV better than that. The reason is, Site B not only has a project, always got an abandonment option. Yes or no? Now, how much better it is? Let us see through the calculation. Everybody, can we start or not? Now, no need to copy. Please participate. Now, here only concentration is required. See. This diagram also there, along with it what? I'm going to draw the other diagram. Don't get clustered with the numbers. So please carefully follow each number which I'm going to put. It seems to be a very big diagram now. Can I proceed or not? Now, don't look at the option A. Look at what? Option B which I'm drawing. Can I proceed or not? Now, site B. Everybody, please. When I do in site B, all of you participate. First year cash flow, those are back. Able to follow or not? First year cash flow can be what? 1 lakh. First year cash flow can be 2 lakh. First year cash flow can be 3 lakh. Everything is going to be almost same. Can I proceed or not? No. Next. When the first year cash flow is 1 lakh, second year cash flow can be what? 0 or 1 lakh or 2 lakhs. Yes or no? Now, but I cannot say like that straight away because at the end of the first year, I have to decide. I have to want to decide whether to abandon or continue. There's a decision box that will come. Yes or no? Because there's no decision, that's going to be what? Decision. I have to make a decision whether to continue or what? Abandon. If the first year cash flow is what? 1 lakh, I can either what? Continue or I can what? Don't continue. Yes or no? If I abandon, I'll be getting an inflow. How much is here? 1,50,000, 1.5 lakh. No probability. That is 100% sure. Yes or no? If I abandon, I'll be getting how much? 1.5 lakh. If I continue, the second year can be what? 1 lakh. Can't be, sorry, what? 0 or what? 1 lakh or what? 2 lakhs. Innappa, right or not? Now, the present value all this 0 or 1 lakh or what? 2 lakhs is going to be how much here? 90,910. This number will not change. So no. Now, the question is, when the first year cash flow is what? 1 lakh, second year I can continue or I can what? Abandon. If I continue, I expect to get what? 19,910. If I abandon, I'll be getting how much? 1,50,000. Which is better? To continue and get 19,910. Abandon and get 1,50,000. Abandon and get 1,50,000. So here I'll not be writing 19,910. I'll be writing what? 1,50,000. Response is or no? Sollupa. No, yeah. End of year 1 I will get. Correct. That's end of year 1 I am writing. The 90,000 also is what? End of year 1. Yeah, correct. Now, when I sell side B, immediate what? Check payment. Are you understand what I am saying? Now. Yeah, can I proceed? Now. So, tell me, if the first year cash flow is 1 lakh. Now, under the mistake, if the first year cash flow is what? 1 lakh. What will I decide? Continue, abandon, abandon. I'll get what? 1,50,000 and not 90,910. Response is or no. Always when I have an option, I exercise to the best of my ability. Yes or no? Now, please, can I proceed? Now, first year cash flow can also be what? 2 lakhs. If the first year cash flow is 2 lakhs, once again what? Decision. What is the decision? Continue or what? Abandon. Abandon simple, I'll be getting how much? 1,50,000. Yes or no? If I continue, I may either get what? 1 lakh or can get what? 2 lakhs or can get what? 3 lakhs. Whose expected personally how much? 1,81,000. Tell me, I will abandon for 1,50,000, continue for 1,81,000, continue for 1,81,000. That's number will be what? 1,81,000. Response is or no? Now, if the first year cash flow is what? 3 lakhs, I can either continue, I can what? Abandon. Everybody follow or not? If I continue, the second year cash flow can be what? 2 lakhs, 3 lakhs or 3,50,000. Whose expected value is how much here? 2,61,000. I will continue for 261, abandon for 1,50,000. Continue for 2,61,000. Response is or no? No. From here onwards similar. Instead of 90, 910, 181, 261, I have what? 1,50,000, 1,81,000, 2,61,000. Yes or no? Now, that means at the end of first year, I may have 2,50,000 or may have what? 3,81,000 or may have what? 5,61,000. Accept or not? Now, will I expect 2,50,000, 3,81,000 or 5,61,000 average? Multiply by average, will be getting what? The cash flow at the end of year one. Discount by what? 1 year. I will be getting now 3,58,000. Believe me, number is correct. 3,58,000. Minus what the investment? 3 lakh. The NPV is what? 58,000. Response is or no? Why it is 14,000 extra? We'll see a detailed discussion later. Do you understand this particular problem, side B or not? Yes, sir. Now, I want a confirmation. Those who understood side B calculation, raise your hand. Or you'll have the clarity or not? Now, this is under side B. We can just copy it and then we can just have a working notes later. Okay, copy this. Now, see, it seems to be a very clustered diagram. Since all branches are there, please copy from side B carefully, please. If you don't have a space in the page, not an issue. Put a counter and write in what? Next page separately a side B also. Important thing is it should be visible for you, clear for you when you revise it later. Okay. What's the difference between the side A and side B diagram here? After first year, I have a decision box whether to continue or abandon. Whichever has got the highest, the best will be what? Selected. Stop talking. But what? அப்படி சொல்கிறேன் ஆமாம்பா இல்லையா இங்கே எந்தப்பா டிஸ்கவுண்ட்டில் தான் இருக்குது இயர் 0 கொண்டு வரணும்பா ஃபஸ்ட் இயர் எண்டில் இருக்குப்பா அது ஆமாம் இயர் 0 கொண்டு வரேன் அது ஒரு வாட்டம் டிஸ்கவுண்ட் பண்ணியிருக்கேன் 2 வருஷம் பண்ணணும்ல அது Stop talking. Those who have not finished copying, raise your hand. Please, fast. Others, those who have finished copying, please maintain silence. One more discussion needs to be made. We'll do that and then go for the next issue. Please. Shh. Stop talking. Please stop talking. Those who not finished copying, please raise your hand. Can I proceed further? Now. Which point here? 1910, huh? Okay, now, see. Okay. Yes, yes. Shall we start or not? No. Please. I'll first once again clarify the doubt regarding discounting and then I proceed with. I asked in site A itself, everybody agreed with that, I don't know. But still you ask the same doubt. What is good for site A is good for what? Site B also. Rumba simple. See. Now, let us take only one branch. First year cash flow 1 lakh, suppose. This 1 lakh happens today, end of first year, end of first year. Second year cash flow can be 0, 1 lakh or 2 lakhs. The average or expert is what? 1 lakh. That happens at the end of first year, end of second year, end of second year. Ennappa, accepted? Yes. 1 lakh received at the end of second year. 1 lakh expected to be received at the end of second year. If I discount by 1 year, if I discount by what? 1 year. From second year, its value jumps to what? First year end. Upon this 90,910 is what? 1 lakh at the end of second year is as good as what? 90,910 at the end of the first year. Yes or no? Now, at the end of the first year, I get the first year 1 lakh, yes or no? And the present value of second year 1 lakh, at the end of first year is what? 90,910. So the totally year 1 end cash flow is how much? 1,90,910. Accepted? This 1,90,910 is at the end of second year, end of first year, today end of first year. So I have to bring it to what? Year 0. Discounted by what? Once again 10%, 0.9091. I bring it to year 0. Respond yes or no. Now other two things are happening. One is, this 1 lakh is discounted by 0.9091. Yes or no? The 0, 1 lakh, 2 lakhs, average 1 lakh, I discount once by 0.9091, other time by what? 0.9091, I will discount it by 0.8264. Enough for it, Same, we have written for what? All the other cash flow. First of all, side A discounting, number obtaining, everybody having the clarity, yes or no? Now, I want you to be pakka before what? Every sum we complete. Are you having the full clarity or not? Now, come to side B. Side B, side A, same only. Both are what? Same. Copy paste. Both are what? Copy paste. Only thing is, only thing, please, I want full silence. Only thing is, at the end of first year, in side A, no other option. Continue for second year. But in side B, at the end of first year, I have a question to ask. Will I continue or I discontinue? Now, I continue. If the benefit is more by continuing, I will discontinue. If the benefit is what? More by discounting. Yes or no? When I discontinue, the benefit is certain. How much is it? 1,50,000. Now tell me, 90,000, 910 better, 1,50,000 better, 1,50,000 better. So when the first year cash flow happens to be 1 lakh, I will not go for what? Second year, I'll abandon the end of what? First year and get 1,50,000 there instead of 90,000. Yes or no? Now, remaining to 1,81,000 better, 1,50,000 better, 1,50,000. So 261 better, 1,81,000. 261 better, 1,50,000 better, 261. So if the first year cash flow happens to be 2 lakhs or 3 lakhs, I'll continue with what? Second year and here the expected cash flow. If it happens to be what? 1 lakh, I'll abandon in what? First year itself and get 1,50,000. That's the only difference. Ennappa right or not? Now, so this is the side B cash flow which I have written and the expected cash flow and net present value. I hope everybody able to understand what I am discussing or not. So when I do the project in side A, the value is how much? 44,000. When I do the project in side B, the value is how much? 58,000. Side B is having 14,000 extra value than side A. Yes or no? Yes or no? What is that 14,000? Value of the option to abandon. Call it value of the option to abandon. I'll show much more. Another way of finding out that 14,000, please. Also another way of finding out that what? 14,000. It may not be exactly 14,000. It will be 13,000 or not. Please bear with me because we done lot of rounding off in the calculation. Right or not? Now, see, you have the numbers in notebook. Huh? Can I just put the slide away or not? Now, listen here. See. When cash flow in first year is 2 lakhs or 3 lakhs, there's no difference between side A and side B because even if I have an abandonment option, it is not useful for me. Yes or no? Correct. If the first year cash flow is 2 lakhs, first year cash flow is what? 3 lakhs. Both in side A and side B, I will do the full project. Yes or no? Side B is favorable to me only when the cash flow is what? 1 lakh in the first year because side A have to continue and earn only 90,000, 910. But side B can earn how much? 1,50,000. That's point. Yes or no? Now, tell me, due to the abandonment option, the extra benefit is how much is here? 1,50,000 minus what? 90,000, 910. What the number here? 59,090. This is going to be what? The extra benefit due to the abandonment option. Yes or no? Now, this extra benefit is in today's terms year 1 end, year 1 year. This is also money to be received at the end of first year. This is also what? At the end of first year. Is the extra benefit what? Year 1 end. Yes or no? Now, next is I multiply by what? 0.9091. Discount by what? 1 year. What is the number here? 1%? 53,790. 190, yeah? 719, okay, some number, 53,790. What that here? Present value of what? Extra benefit. Respond yes or no? Now, getting this extra benefit is 100% sure, unsure. This will be obtained only when the first year cash flow is what? 1 lakh. Normally it is 2 lakhs or 3 lakhs. So to get this extra benefit, the probability is what? 0.25. So tell me, what is the expected extra benefit here? 1%? 13,000? 4? 13,430. Round it up to what? 14,000. All rounding up numbers are that. Respond yes or no? Now, this is the present value of expected extra benefit when I have what? Option to abandon. Is the value of the abandoned option? Yes or no? No. Very simple. Value of the project 44,000. Accepted? And value of the option is what? 14,000. Project alone, value what? 44,000. Project with the option value is what? 15,000. Response is or no? The earlier problem is a project with expansion option. In this problem, it's project with what? Abandonment option. Expansion option gives you scope to earn more revenue. Abandonment option gives you what? So as a scope to earn more revenue by going for the best option, whether abandoning or what? Just continuing with the project. Response is or no? And will the option value be negative or will not be negative or will not be? For example, all the 3 years, so it is more than 1,50,000. Now what I will do? I will not exercise the option. Option value can either be 0 or what? Positive. Never can an option value be what? Negative. Is what is the next issue you have to understand it. Response is or no? Now answer my question. Site A, what is the NPV? 44,000. Site B, what is the NPV? 15,000. Site A is the NPV of the project. Site B is what? NPV of the project along with what? Value of the abandonment option. What the project standalone value? 44,000. What the option value? 14,000. How I got option value? Option does not have the value in case of second as well as what? Third scenario. It gets value only in case of what? First scenario. What the first scenario? When the cash flow is 1 lakh. If I don't abandon, I get only 19,910. If I abandon, I get how much? 1,50,000. Due to abandonment, how much I get extra? 59,090. Is the value at the end of first year. What the present value of the value? It is 53,000 and off. To get this option value, what are the chance here? 25%. So the expected option value is how much? 14,000 approximately is the value of the abandonment option. Response is on no. No. You have seen 2 real options. 1, 2 real option. Option to expand, option to abandon. All this, the next chapter we are going to start these options. We are going to start with the next chapter. Once I complete the capital budgeting, starting with the chapter called as what? Options. Very in-depth and very good chapter in the area derivative. At the end of the options, I will do 2 capital budgeting problems like oil reserve, how to find out what expected value and building expected value and so on. In that we'll be using much more intricate techniques or scientific technique to what value the option much more carefully. Everybody following on it now. These are all the overall simple problems in option valuation. More good problem can be seen when you just complete the chapter option, which happens to be the next chapter. Everybody are you following or not? Now with this we complete this particular discussion. Now see, I need not calculate the 50,000 this way. Simply I can say what? NPV of the project is 44,000 plus NPV of the option is 14,000. We can calculate and then put the solution. Can you start or not? Right now. Next. Why? We can just write the answer like this as a question. Okay. Why Site A and Site B has different NPVs? Why Site A and Site B has different NPVs? Why Site A and Site B has different NPVs? Why Site A and Site B has different NPVs? Question mark. In Site A, it is standalone project. In Site A, it is standalone project. And in Site B, it is a project along with. In Site B, it is a project along with, please fill in the blanks, it is a project along with what? An option to abandon. It is a project along with an option to abandon. It is a project along with an option to abandon. This is point number 1. This point number 1. You are answering the question in different points. Point number 1 over. Yes or no? Right now. Next. Point number 2. The value of abandonment option. Point number 2. The value of abandonment option can be calculated as follows. Point number 2. The value of abandonment option can be calculated as follows. The value of abandonment option can be calculated as follows. Isn't that right? Abandonment value 1,50,000. Abandonment value 1,50,000. Expected cash flow from continuance 90,910. Abandonment value 1,50,000. Expected cash flow from continuance 90,910. Extra benefit on abandonment is equal to extra benefit on abandonment is equal to how much? 59,090. Extra benefit on abandonment is equal to 59,090. Next, present value of extra benefit. Present value of extra benefit is equal to present value of extra benefit is equal to what into what? 59,090 into 0.9091. Present value of extra benefit 59,090 into 0.9091. 53,719. Present value of extra benefit 53,719. Sorry, can I proceed? Now, continue. This value can be obtained only when this value can be obtained only when this value can be obtained only when year one cash flow is this value can be obtained only when year one cash flow is only when the year one cash flow is what? 1 lakh. This value can be obtained only when year one cash flow is 1 lakh, whose probability is what? 0.25. Whose probability is 0.25. Next line. Hence, the expected present value of abandonment option is the expected present value of abandonment option is 0.25 into 53,719. Is 0.25 into 53,719 is equal to how much base? 13,430 is equal to 13,430 or what? 14,000 approximately. So that's why I said don't fight with me for the rounding up. It happened in different stages, okay, or 14,000 approximately. Can I proceed or not? Now, next, last point. Point number 2 or 3? 3. Value of the project is equal to, point number 3, value of the project is equal to, I want to know what is the value of the project? 44,000. Value of the project is equal to 44,000. Kadapa? Both sides, value is 44,000 only, yes or no? Value of the project is 40. Side A and side B, same project, yes or no? So value of the project is equal to 44,000. Value of the project is equal to 44,000 and value of the abandonment option. Add value of the abandonment option. Add value of the abandonment option. How much will be? 14,000. Add value of the abandonment option 14,000. Next, value of the project with option. Value of the project with option by the total. What is the value of the project with option? 58,000. Value of the project with option 58,000. Value of the project with option 58,000. So site A only project, site B is what? Project and option. Hence it becomes what? 58,000. This point is or no? Write down. Last point. Point number 2 or 3. I don't numbers only. 4. An option can have 0 or positive value. This is very important. This is going to be the basis for the entire option chapter. Are you following? An option can have 0 or positive value. Can never have. An option can have 0 or positive value, but can never have what? Negative value. but can never have negative value. An option can have 0 or positive value but can never have negative value because if situation is unfavorable, if situation is unfavorable, the holder will not exercise his option. If situation is unfavorable, the holder will not exercise his option. If situation is unfavorable, the holder will not exercise his option. The holder will not exercise his option. I want everybody to respond. Full clarity is there or not? No. I have not completed the sum. The answer is over. We have one more discussion to make to compare the two decision trees. Yes or no? Why I have done a different tree earlier? Why I have done a different tree now? And when you should use which decision tree? And then go for the next problem. Can I proceed or not? Now, my question first is, should I switch on the AC or not? After 5 minutes, okay, please. Question over. Can I proceed now?